You don't have a note sheet for this, so you're going to have to write it on a piece of notebook paper or, back of a receipt, whatever you'd like. But we're going to continue with limits. For this one, we're going to be working with the difference quotient. So we're looking for the function f of x equals 2x squared plus 1, and we're going to find the limit as h approaches 0 of f of 2 plus h minus f of 2 all over h. Well, you remember from doing the difference quotient, and I know you guys loved it, you have to find each of these parts separately. So we're going to start by finding f of 2 plus h. So I'm taking 2 plus h and substituting it in for x into the expression 2x squared plus 1. So it's 2 times 2 plus h, the quantity squared, plus 1. And then you want to simplify this. Multiply this out, you have to FOIL, so you get 4 plus 4h plus h squared. And if you're like, whoa, what happened there? That is 2 plus h times 2 plus h. FOILed will give you this. Distribute the 2. And then I'm going to put this in order and combine like terms. So 2h squared plus 8h plus 9. That gives me the first part of my numerator. I also need to know what is f of 2. So my x now became a 2, so my x here must also become a 2. So 2 times 2 squared plus 1. Well, 2 squared is 4, times 2 is 8, plus 1 is 9. Now we have both parts of our numerator. We have our denominator because it's not being substituted in. So we can find the limit of h approaching 0 of the quantity 2h squared plus 8h plus 9 minus 9. So I substituted in this quantity here, minus f of 2 we found was 9, and this is all over h. Notice I haven't dealt with this limit component at all at this point. And now limit as h approaches 0, again, not dealing with that at all. These two will cancel, plus 9, minus 9. Everything is divisible by h, so I'm going to, well, let me just show you the steps so I don't confuse you. Think of this as two separate fractions, 2h squared over h plus 8h over h. I literally have split these into two separate fractions, and this is the whole limit here. So you have the limit as h approaches 0 of 2h plus 8. Okay, now we're really just combining two things you already knew how to do, which was find the difference quotient and simplify down to 2 plus h. And now we're back to a regular limits problem where the first thing you always want to check is, can you do a direct substitution? And you can. 2 times 0 plus 8 will give us 8. So this function equals 8. The uses of the difference quotient is to find the average rate of change at an instant in time. Unlike where we had previously, a rate of change is the slope of a function over an interval where we do rise over run. That's over that line. But if you have some sort of curve that's turning, and like a sine curve or something even kind of crazier than that, you would use a derivative, and you would be looking at any instant in time. So the formula for a derivative is right here. It's a difference quotient as a limit as it's approaching 0, provided there is one. So jot this down in your notes, and then we will do an example of one. Okay, jot down this example. Find f prime, that's how you read this, f prime, for f of x equals the square root of x plus 1. Note the plus 1's outside. Then find the slope of the graph of f at the point 4, 3. So if you graph this, let's try that first. I can get that set up while you're copying down this example. Okay, so looking at this graph, at the point 4, 3, what is the slope of this curve? Well, 4, 3 would be out here, so just at that point right there, what would the slope be? Okay, so we have to start by using our formula for a derivative, f prime of x, or f prime, is the limit as h approaches 0 of f of x plus h minus f of x all over h. Okay, so we already know what f of x is, so we're good to go there. We need to find f of x plus h. So I'm going to substitute x plus h into the expression square root of x plus 1. That's going to be the square root of the quantity x plus h plus 1. Does not appear that we can simplify that, so we will come over here. The limit as h approaches 0 of the square root of x plus h plus 1 minus the square root of x, shouldn't have closed that parenthesis there, plus 1, sorry, all over h. Okay, because we have these square roots going on, to simplify this limit, we're probably going to need to use the multiply by the conjugate of the numerator. So I notice I canceled off the plus 1 and the minus 1 because this negative is being distributed here. Okay, so I'm going to write this down. The limit as h approaches 0 of the square root of x plus h minus the square root of x all over h, multiplying that by the conjugate of the numerator, square root of x plus h plus the square root of x all over the square root of x plus h plus the square root of x. So numerator and denominator are the same, so essentially I'm multiplying by 1. The conjugate just means you change the sign between the two terms. It was originally minus, so now it's plus. We're going to distribute. Because you have conjugate pairs, the inners and outers will cancel. When I multiply the first together, the square root of x plus h squared minus the square root of x squared I apologize, that was my ringtone. Multiply those together. Now we're going to not distribute in the denominator. Simplifying yet further, the square rooting and the squaring will cancel on all of these. Notice here we have an x and a minus x, so we have the limit as h approaches 0, sorry, these should be zeros. You have h now in the numerator because x minus x canceled. In the denominator, we're going to just leave it be. Now the h's will cancel, left with 1. At this point, you can find the limit using direct substitution. If you substitute in 0, you get 1 over the square root of h. the square root of x plus the square root of x (1 over 2 square root x). If you rationalize that, you would get the square root of x over 2x. I think we'll just leave it like this for now. So you would write this as f prime, or the derivative of f, equals 1 over 2x. 1 over 2 square root x. There we go. The second part of this says, then find the slope of the graph of f at the point 4, 3. The slope at point 4, 3. Now, we only need to worry about our x's here, so that is a direct substitution of 4, which will give you 1 over 2 square root 4. And that is 1 over 4. Okay, so there will be an assignment for you on Schoology dealing with all of this difference, quotients, and limits. I hope you guys are doing well, and we will see you after graduation.